Hello everyone, I'm Isaac and this is my video lab report for Lab 3 Magnetic Fields. The purpose of this lab is to gain an understanding of the relationship between the strength of magnetic field and the distance the observation point is from the magnet. By finding this relationship, it is then possible to calculate the moment of a magnet, which in some ways gives us an understanding of the strength of a magnet compared to other magnets, independent of distance. Through this lab, I calculated a magnetic moment of about 2.61, though it is likely inaccurate due to errors discussed in the rest of the video. The first part of the experiment was to measure the magnitude of the magnetic field at a selection of points with the magnet perpendicular to the magnetic field of Earth so that did not come in and mess up the calculations. This should mean that any magnetic field readings for the X component should only include the magnetic field created by our magnet and not magnetic fields created by something else. Using these calculations for the X component, we predict the form of the magnetic field to fit the form of the calculation where the magnetic field is equal to some constant k times the distance r raised to an nth power. Taking the natural log of both sides gives us this equation shown here, which allows us to find a line of best fit based on our collected data, which is on the graph to the side. This gives us a k value of -14 when you raise to the nth power to help you calculate k, and then an n of -3.4, which the rounded nearest integer is -3, which when put into the equation gives us a magnetic field of k times r to the -3, which is, when you rearrange it a little bit, is very similar to the on-axis calculation for a magnetic field of a dipole. So we should be able to use that k value we talked about earlier to find the magnetic moment, which again, to reiterate, is calculated about 2.61. In the last part of the experiment, the magnetic field was calculated at a point that was 45 degrees off axis, where it was 15 centimeters away from the magnet in the x direction and the y direction. This gave us this vector and gives us a useful point to compare the accuracy of our computer model compared to our experimental model. In this computer model, we use a more developed form of calculating the magnetic field of a dipole, so we are no longer dependent on the axis, on being on axis or perpendicular to the magnet. Then this calculation is implemented in the Python code here, where most of the stuff is just a code implementation of this equation above. And as we can see from our computer model, when we graph it on axis and perpendicular, we get the results we would expect based on our approximations, where the directions are correct and the on-axis magnetic fields look to be about double and are clearly double the perpendicular ones. And then of course we found the magnetic field based on our computer model for these points, which, going into it and bringing back up the experimental and computer model, they are not quite as similar as you would hope, and this is likely due to error involved in calculating the magnetic moment, which when we go back to this calculation is because our n value here is not exactly -3. This could be to a number of reasons, such as not properly aligning with the magnetic field, which is more discussed in the what if questions, inaccuracy in distance measurements where being off by a centimeter could throw off results, or magnetic fields generated by other objects such as the computer or somebody else's phone that would throw off the results as well. So let's finish off with the what if questions, and then the first one is what if you had oriented your experiment to compensate for the magnetic north, and this would mean that when you find the magnetic field for the x component and the y component would both include the magnetic field, which means there would be a constant magnetic field added to whatever the magnetic field of the magnet was, and so those would be pretty much inseparable, so you wouldn't be able to fix that calculation unless you figured out what the field of magnetic north was, which you wouldn't be able to do unless you did the experiment right the first time around anyway. And then what if you were to stick two identical magnets together and to end and run the experiment again? How would you expect the results to differ? With two identical magnets together and to end, you would expect the magnetic moment to approximately double, which is for once the intuitive result here, because magnetic moment is dependent on area, and that doubled as well. And then also you can consider distance far away from the magnet. The difference in position of the two magnets is negligible at that point, so using superposition, you can add the magnetic field generated by both those magnets to get your result. Though, of course, in that case, in this experimental case, because of the inaccuracies in finding our K value, or the strength of the magnetic moment, it probably would not actually end up doubled.